Subtopic 5.7 Electrical Device. So in this subtopic, we are going to learn two devices. The first one is Wheatstone bridge and second one is slide wire bridge. Basically, they have the same function. Just Wheatstone bridge, we use 4 resistors. Meanwhile, for slide wire bridge, we use only 2 resistors. So let's focus on Wheatstone bridge. It is a device that can use to determine the resistance or unknown resistance by balancing potential drops in a circuit. So this is the example of the circuit. It consists of 2 resistors with known values, which is R1 and R3. Meanwhile, we have a variable resistor or known as rheostat, perintang boleh laras, with resistance of R2, and this is the unknown resistors Rx. So here in between R1, R2 and R3, Rx, there is a galvanometer connected between these 2 points. The function of this galvanometer is to measure the potential drops or potential difference at these 2 points. Okay, what happens if we arrange the resistor in this kind of arrangement? So the current will flow from this positive terminal and then it will meet a junction. It will split into the first current will flow through R1 and R2. Second one will flow through R3 and Rx. So we can adjust this rheostat. Okay, we can adjust the value of resistance here. If either we want to increase the value of resistance or decrease it. So why do we need to change the value of resistance right here by using the rheostat? We want to make sure that through the galvanometer, we will get the value for potential difference is equal to 0. Kita nak bacaan pada galvanometer ni menunjukkan 0 volt. So, dengan cara ubah nilai pada perintang boleh laras, okay, bila dah galvanometer tunjukkan nilai 0, kita boleh katakan bahawa the bridge, okay, bridge ni jambatan di antara point D and point B here, is balanced. Okay, so kalau balance, kita boleh buat satu equation ratio and from there, we will have an equation that we can use to find the value of unknown Rx right here. Okay, so when the galvanometer shows 0 volt, the circuit or the bridge is balanced. So the potential difference at R1 is equal to the potential difference at R3. We can write it as V1 equal to V3. Meanwhile, the potential difference on R2 is equal to the potential difference on Rx, Vx. So let's say this is the first equation, second equation. So we can combine them together. Equation 1 divide with equation 2. Then you will have V1 over V2 equal to V3 over Vx. So according to Ohm's law equation, V is equal to IR. So we can write it as I R1. Okay, let's say the current that flows here is I1. Meanwhile, the current that flows here is I2. I1 and I2. So it will be I1 R1 for V2, potential difference dekat V2 R2 ni. The same current flows through R2. Okay, so it will be I1 R2 equal to, for V3, current that flows through R3 is I2 R3, and for Rx, I2 juga lalu dekat Rx, so Rx. So here we can cancel out the value for I1 and I2. Okay, this one is not a junction, yeah. This is not a junction. Yang ni just sambungan galvanometer untuk kita detect potential difference dekat these 2 points. So don't you say that this is a junction, so dia akan jadi parallel. No. R1 and R2 is in series. R3 and Rx also in series. So from here, you will get the equation. We can rearrange it. So Rx is equal to R3 times R2 over R1. So you can substitute the value for each resistor to get the unknown resistance Rx in the unit of ohm. From here, kita boleh nampaklah function of Wheatstone bridge is to determine the value of unknown resistance by using this arrangement and make sure that the potential difference between these 2 points equal to 0 so that the circuit or the bridge is balanced. So macam nak jadikan dia 0? Kita ubah nilai resistance pada perintang boleh laras ini. So these are the explanation. Why do we need to adjust the variable resistor until the galvanometer shows no deflection or 0 volt. So this means that the equilibrium has been reached and no current flow through it. Okay. Okay, so this is actually the same thing that I have write down. Okay, daripada equation. Potential difference yang mana sama dengan apa. And then from here we can derive the equation until we get the equation to find Rx. So actually yang equation ini bukanlah untuk you hafal. Okay, sebab apa? Kalau susunan resistor tu berbeza dalam circuit tersebut ataupun mungkin digunakan label yang berbeza, so that you will get different kind of equation. Okay, what you need to do is fahamkan konsep Wheatstone bridge, potential difference yang mana yang akan sama dengan potential difference yang mana satu. Kemudian you derive the equation, when you get your own equation, baru you masukkan nilai dan you akan dapatlah the unknown resistance value. Okay, same goes to slide wire bridge. Okay, this is a modified form. Okay, what happened is, kalau tadi kita ada 4 resistor, satu rheostat dan satu lagi unknown resistor. So now, kita akan gunakan 2 resistor sahaja. We have a power supply right here. And then, dekat board ni, kita ada 2 resistor, let's say R1 dan juga Rx. R1 ni kita tahu berapa nilai dia. Rx ni unknown resistance. And then, kita ada satu wire panjang made up of besi. And then ada slider kat sini. Slider ni kita akan gerakkan dia sepanjang wire besi ni. And then, it will detect the presence of current lah. Sebab current akan lalu through this wire bridge kat sini. So, in the middle between R1, Rx dan juga this slider, okay, kita sambungkan dengan galvanometer. Okay, fungsi dia apa? Bila kita gerakkan slider ni, galvanometer akan bagi bacaan the potential difference between this point and this point. So, kita gerakkan sampai galvanometer shows 0 volt. So, we can say that the bridge is balanced. So, bila dah galvanometer shows 0 volt, stop at that point. Measure the value of L1 and also L2. Okay, so the total length of this slide wire bridge is 1 meter. Usually we will use 1 meter. So from here we can say that the potential difference across R1 is the same as the potential difference dekat L1. So ataupun okay, kita juga boleh tulis sebagai R1 is directly proportional with L1. Okay, remember the factors that influence resistance. Okay, semakin panjang wire, semakin banyak dia punya rintangan. So, R1 is directly proportional with L1. What about Rx? Rx akan directly proportional with L2. So, from here, kita boleh equalkan equation 1 dengan equation 2. We can say that R1 over Rx is equal to L1 over L2. So, from here, you can substitute the value of R1, L1, L2, and you will get the value of Rx. Okay, let's see another diagram. So, we have a resistor R3, Rx, this slide wire bridge. This wire has L1 and L2. Maksudnya, bila kita gerakkan slider kat sini, okay, kita gerakkan at this point, when the slider is here, the galvanometer will show 0 volt. So that the bridge is balanced or the circuit is balanced. Then you can come up with this equation. You can see that R3 is directly proportional with L1. Meanwhile, Rx is directly proportional with L2. Okay, always refer to the diagram. So we can write down our equation as here. Equation 1 divided with equation 2. R3 over Rx equal to L1 over L2. Then you can substitute the value that you have to find the unknown resistance Rx. Okay, you can also rearrange it like this. Rx equal to R3 L2 over L1. Okay, let's do this example. 5.15. A Wheatstone bridge is balanced. So when it comes to bridge balance, galvanometer will show 0 reading. R1 is 20 ohm, R2 is 10 ohm, R3 is 15 ohm. Determine the resistance of an unknown resistance Rx. So from here, we can see that the current flow from here, and then it will split into two. Let's say this is I1. And then here we have I2. Okay, since the bridge is balanced, so tak akan ada current yang flow through this wire. Okay, so the potential difference from here to here is equal to 0. So we can also say that potential difference at R2 sama dengan potential difference dekat Rx. Itu equal to Vx. Potential difference dekat R1 equal to potential difference dekat R3. So we can divide these two equations where V2 over V1 equal to Vx over V3. Or you can also write it as V1 over V2 equal to V3 over Vx. So we already have, we already know that V is equal to IR according to Ohm's law equation. So I1 R2 equal to I1 R1, and therefore V I2 Rx over I2 R3. So we can cancel out the I, substitute the value for R, 10, 20, unknown, and 15. So you will get Rx equal to 7.5 ohm. For example, 5.16, we have a 1 meter wire which is measured from here until here, connected to a battery, two resistors S and T. So we have resistor S and also resistor T. Calculate the distance from A to J, which is from here until here. Kita nak cari panjang L1 when the circuit is balanced if the resistance of S and T are 4 and 3 ohm respectively. So dia dah bagi tahu dah circuit is balanced. So we can use the ratio where resistance S is directly proportional with L1. Meanwhile, resistor T is directly proportional with L2. So these two equations kita boleh make it a ratio. So we have Rs over Rt equal to L1 over L2. To find L1, we need to know what is L2. So macam mana nak dapatkan L2? L2 ni sebenarnya sama juga dengan total length which is 1 meter minus L1. Okay, you akan dapat equation ni lah. So kita akan masukkan 1 meter tolak L1 ni into this equation. Resistance S is 4 ohm. Resistor T is 3 ohm. L1 over 1 minus L1. Okay, from here we can solve for L1. We can bring it to this side and 3 to this side. So we will get 4 minus 4L1 equal to 3L1. So 4 equal to 3 plus 4 is 7L1. So L1 is equal to 0.57 meter. If you want to know what is the value for L2, so 1 minus 0.57 meter, then you will get 0.43 meter. Okay. So we have learned from this chapter, we have learned about the current and also the electric charge, the Coulomb's law, which is, this is actually from chapter 3, the electric field that will produce current,